Passport to Advanced Math Lesson 12 is all about simplifying rational expressions. This is standard number 9, which is basically rewriting simple rational expressions. With this, rational expressions are not easy, but they really don't make it too difficult if you just have a basic idea of what you're doing. So let's take a look at some examples and strategies for the following problems. Now, a lot of these examples are no calculator, but it all is all basic math. So the first example says, the expression above is equivalent to a over x plus 2 all squared, where a is a positive constant and x cannot equal negative 2. And the reason x can't equal negative 2 is because anytime you have a fraction, a denominator cannot equal 0, and negative 2 makes it equal 0. So it's relevant to the problem, but not to what you need to accomplish. So what you have to do is figure out what would the value of the numerator be after you simplify it. Well, they basically, anytime you add or subtract fractions, you need a common denominator, right? So if I had something like 2/3 and plus 3/12, right? My common denominator would be 12. And then I'd have to figure out how to write this equivalent fraction with the denominator of 12, and then go from here. Same thing here. My common denominator, they're basically telling me, is x plus 2 all squared. So I'm going to write x plus 2 all squared down here. And if I look, this denominator is already matches that. So I'm just going to rewrite that numerator. Now I'm going to right away make this plus a negative. And if I look to turn this into x plus 2 all squared, what I basically have to do is multiply by another x plus 2. I'm going to go ahead and multiply the numerator by x plus 2 because what I do to the denominator, I have to do to the numerator. Now when I distribute, negative 2 times x is negative 2x, negative 2 times 2 is minus 4, and now when I simplify the numerator, 2x minus 2x, x's eliminate, 6 minus 4 is 2 over x plus 2 all squared. So what's in the place of a? 2. And that would be the number you bubble in. Okay. Next one. Says if x is greater than 3, which of the following is equivalent to this expression? Now, again, if x is greater than 3, just tells you where this function basically would exist, all right? Other than that, you're just basically trying to write this to look like one of these here. So here's the thing. When you go to do this, the first thing I'm going to do is simplify this denominator. Now I'm going to write that over on the side. And then what I'm going to do is find my common denominator by adding what I see in each of these denominators. So I have an x plus 2 here, so I'm going to write it down. I have an x plus 3 here, so I'm going to write it down. Now, to make this denominator equivalent to that, what do I have to multiply numerator and denominator by here? It's missing the x plus 3, so I'm going to multiply numerator and denominator by x plus 3, and I'll distribute that 1 to get x plus 3. What am I missing in this denominator? X plus 2. So I'm going to multiply the numerator by x plus 2. 1 times x is 1x. 1 times 2 is 2. And now, if I simplify my numerator, x plus x is 2x. 3 plus 2 is plus 5, all over x plus 2 times x plus 3. Now, when I look here, you have to recognize that the answers here don't use x plus 2 or x plus 3. What they basically do is multiply these out. So this would be the same as 2x plus 5 over, if I FOIL this out, I get x times x is x squared, x times 3 is 3x, 2 times x is 2x, 2 times 3 is 6. So I would get x squared plus 5x plus 6. So now what we're going to do is rewrite this problem as 1 over 2x plus 5 over x squared plus 5x plus 6. And it's much easier to read this as 1 divided by 2x plus 5 over x squared plus 5x plus 6. And if you remember, when we divide fractions, we keep the first one the same. We change division to multiplication. And then we take the reciprocal of the divisor. So x squared plus 5x plus 6 over 2x plus 5. And when I multiply this out, I end up with x squared plus 5x plus 6 over 2x plus 5, which ends up being letter B. Okay, the next one has you take a rational expression and use, or kind of have an idea of that polynomial long division, sometimes synthetic division if you look at it. But what it says here is the equation, right? This equation is true for all values of x that are not equal to 2 over a. And the reason it can't equal to 2 over a, because that's what would make the denominator equal 0, where a is a constant. So this here is important to know. A being a constant just tells you a is a number, right? 2 over a is just telling you what value of x makes the denominator equal 0, which we cannot have in mathematics. So basically, if I went back to like Math 3 and talked about polynomial long division, that would go inside the box, and outside the box would be the ax minus 2. Now what I'm going to do is, if you look, what they give you here is your quotient. That's what you get when you do the polynomial long division, which would go up here. Negative 8x minus 3 minus 53 over that ax minus 2. So basically, to find this, I like to work smarter, not harder. What would I have to multiply ax by to get 24x squared, right? But I know I have to do negative 8 times that value. So negative 8x times what would give me 24x squared? Well, negative 8x, if I divide, all right, or just use common sense that it's got to be negative 3x is what you would get. Now, that basically tells you this is what I would have to multiply negative 8x by. What is in the place of a? A would be negative 3, which is letter B. Okay, the next example. What they're giving you now, it says, which of the following is equivalent to the expression above, right, for x is greater than 0. So right now they're telling you after you divide, that is what you get, okay? But they give it to you almost backwards. If you look, this here is technically your remainder. So we should rewrite this as 5 plus 1 over 2x plus 1. So right away, if I think about this, 2x plus 5 goes in the box. 2x plus 1, what times 2x would give me 2x? That would be 1. Is that going to match up with the 5? No. If I do the next one, it's going to be the same thing. If I use polynomial long division, that would be 1 plus something with my remainder. This one, if I use polynomial long division, 10x plus 5 divided by 2x plus 1, what times 2x would give me 10x? That would be 5. Now, that one is possible. If I do the same one here, right, 10x plus 6 in the box, 2x plus 1 outside, let's just see if that matches up. What times 2x would give me 5, or 10x? That would be 5. So now, what I have to do is determine which one would give me a remainder of 1. So if I multiply here, 5 times 2x is 10x, but remember we got to subtract it. 5 times 1 is 5, right? But when I bring it down, I have to subtract it. That would give me a remainder of 0. That's not going to work. If I distribute here, remember when I multiply and bring it down, I have to change the sign. 5 times 2x is 10x. I'm going to go ahead, subtract it. 5 times 1 is 5. I'm going to go ahead, subtract it. 6 minus 5 is 1. And that's my remainder. So I know letter D would be the answer. Okay. Obviously, there are easier ways for you guys to determine which ones to eliminate right away, but I want to show you the approach to each one. So the next example, right? When you look at this, again, you know you're dividing this, and it's much easier to use polynomial long division. Now remember, when we use polynomial long division, you must have all your terms from highest exponent to lowest and fill in zeros with any missing terms. That goes on the outside. So right away, what I do is step by step. What times 4x would give me 4x squared? Well, 1 times 4 would give me 4. X times x would give me x squared, so it's 1x. Distribute that, and I get 4x squared, but remember, I have to subtract it. 1x times 2 would give me 2x, but when I bring it down, I have to subtract it. Those eliminate. 6x minus 2x is 4x, and then I'm going to bring down the plus 0. Oop. Now, right away here, all of my first answers make sense because the first term is x. Now I have to do the next step. What times 4x would give me 4x? Well, 1 times 4x would give me 4x. So now I'm down to x plus 1. So right away, once I do that, I don't even have to go any further because that doesn't make sense because my quotient is going to be x plus 1. This doesn't make sense. This doesn't make sense. The only answer right now that would make sense is letter D. And if I finish it out, 1 times 4x is 4x. Go ahead, subtract it. 1 times 2 is 2. Go ahead and subtract it. And I get negative 2, which is my remainder. And that's why it's minus 2 over 4x plus 2. The next problem is a little more complicated. And it's only because you have to remember an important concept from back in the day. If you want to evaluate a function, right? If you remember, there's 2 ways to do it. You can plug that value in, or you can use synthetic division, right? And when you use synthetic division, at the end, you would get your remainder. And after you use synthetic to divide, the remainder would be the value, right, after you input it, right? And this is basically the remainder theorem, that if you want to evaluate a function, you could use synthetic division, and whatever your remainder is would be what the value of that function would be with that input x. So it says, for a polynomial p of x, the value of p of 3 is negative 2. Which of the following must be true about p of x? Really, they say x minus 5 is a factor of p of x. You really can't determine that from the given. X minus 2 is a factor of p of x. Or x plus 1 is a factor. Remember, if any of these are factors, right, you would have to have a remainder of 0. So that can't work. But if they tell you p of 3 is negative 2, they say the remainder when p of x is divided by x minus 3. Remember, when you have x minus 3, you always put the opposite in the box. And if you get a remainder of negative 2, that would be the value. So letter D would be your answer here. Remember, if it's a factor, right, you would have a remainder of 0. So the next one, the expression 5x minus 2 over x plus 3 is equivalent to what, which of the following? So again, anytime you see this, anytime they ask you for this, look at your answers, right? They give you as a quotient plus a remainder over the denominator. And remember that that's always going to be the quotient plus the remainder over the denominator. So right away, that's telling you that you have to use polynomial long division. So remember, your numerator goes in the box, denominator outside. What times x would give me 5x? That would be 5. 5 times x is 5x. I'm going to subtract it. 5 times 3 is 15. I'm going to subtract it. Now, negative 2 minus 15 is negative 17, right? Can I multiply anything by x to get negative 17? No. So this is my remainder. So it would be 5, then plus negative 17 over my denominator. Now, as you see, this is not one of your answer choices because what they do here, that doesn't make sense, that doesn't make sense, that doesn't make sense. But here, minus 17 over x plus 3 is the same as plus negative 17 over x plus 3, which is letter D. And the last one here. For which of the following x is the function h above undefined? Remember, this is undefined, right? It's undefined when the denominator equals 0. So what we have to do is find the value of x that makes this denominator equal 0. Now, this is a calculator problem, and I'm going to tell you 2 ways to approach this, okay? And it's very important to pay attention here. Now, what you have to understand is this problem is a calculator-based problem. So the quickest way, right, to find the value of the variable that makes that denominator equal 0, that is not a fun equation to solve. I'll tell you that right now. So what you want to do, use your handy-dandy calculator, right? Remember, I can look at that and know that it's going to be a quadratic, right? And if it's going to be a quadratic, what I'm going to do is just plug that into y equals, right? So x minus 5 all squared plus 4 times x minus 5 plus 4 all in the calculator. And I'm only putting the denominator in the calculator because that right there, right, is basically what I need to equal 0, right? Now, what I'm going to do then is I'm going to hit graph. And if I look, where does this quadratic hit, or what's the x-intercept of this quadratic? Isn't it at x equals 3? Right away, if you think about it, x equals 3 is the value of x that makes it equal 0. Therefore, this is undefined when x is equal to 3. Now, another way to approach this graphically is I'm going to just plug this in the calculator as I'm going to hit alpha, y equals, hit enter. I'm going to go 1 over, and now I'm just going to put my denominator in. X minus 5 all squared plus 4, open parentheses, x minus 5, close parentheses, then plus 4. And right away when I hit graph, notice here, right, I get this weird thing. If you remember, what do we call this here, right? You don't see it here, but right away if I go to the table, I'll notice at 3 it says an error, right? The function is undefined in that point, so there's technically, if you remember, an asymptote there. And if there's an asymptote there, basically it's undefined when x is equal to 3. So that's 2 ways you can approach this graphically. Now, you could solve it algebraically, right? But that's not going to be fun. You're better off solving it graphically. Okay?